This is problem 4.3.37. We have a growth function for an aquatic species, and we want to find the growth rate at equals 7 because we want the growth rate. We're automatically going to think we want to find the derivative. Okay. Now I look at this function, and I'm going to think about using the quotient rule. Technically you could rewrite it, but I'm just going to use the quotient rule here, because I think that's probably what you guys would do instinctively. Okay, so I have my top and my bottom, and the derivative with the quotient rule is you do the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So in our case, the derivative of this growth function would be the bottom, so 1 plus 16 e to the negative 0.52t times the derivative of the top. Now the derivative of 40,000 is just going to be 0. Okay, minus, make sure you have a minus there. My top is 40,000 times the derivative of the bottom. So derivative of the bottom, derivative of 1 is going to be 0. 16, we'll keep that 16 there. So 16. Now when we do e to a function, any function, so we'll put our little box around there, it stays the same. So it's going to be e till we keep it exactly the same, so negative 0.52t. Okay, now times the derivative of what's inside your box, so times the derivative of negative 0.52t is negative 0.52. All over the bottom squared. Now at this point, I could simplify, like this bottom, that squared, I'm not going to multiply that out. That would take more time than it was worth. So I'm just going to go ahead and plug in 7 and simplify with my calculator, since in the end I just want an answer, or a numerical answer, not the actual derivative. So we're going to have negative 40,000 times 16e to the negative 0.52 times 7 times negative 0.52 all over 1 plus 16 e to the negative 0.52 times 7 squared. And we're going to make sure we put this in our calculator very carefully. So I put in my calculator, I did the top and bottom separately just to make it a little bit simpler to keep track because there were so many pieces, and I get 4,332.6, and the problem did ask me to round to the nearest whole number, which I think they did an all-in-one computation because they rounded down to 432. 432. Sorry, I can't say that. 4,332. And that is going to be our answer.